So we're moving into our next conic section, our ellipses. Geometrically, the ellipse is a set of all points in a plane where the sum of the distance from two fixed points is always going to be the same. Those fixed points, we call them foci. That's our plural of focus. So if we have an ellipse and we pick a point and we have these foci, multiple focus, within inside the ellipse, the distance from the point to each of those, when we add them up, is the same as if I have any other point on that ellipse and the distance between those points. Okay, so the sum of the black lines will be the same as the sum of the blue lines, always. Okay, and that's how we form that ellipse. Okay, so that's our geometric definition. We have the equation for an ellipse. The one that's given here is centered at the origin, because you'll notice we don't have an h or a k value. Just like with our circles, h and k refers to the center. So once I move off the origin, then it's going to look a little more similar to our circles equation. And we're going to have the formula x minus h squared over a squared, y minus k squared over b squared equals 1. Okay? So very similar to our circles equation, but now what we're doing is we're adding in some fractions. We have these denominators, and that's what causes that kind of stretch in the circle, is that denominator. On the next slide, I'll show you two formulas. It's the same one, but just using the commutative property to switch the x's and the y's, okay, to switch the location, just two fractions. It's addition, so it doesn't matter the order, but I'm going to go over a few important features that you need to be aware of when we're looking at the equations and when we're writing our equations. Okay? So an ellipse is basically an eccentric circle. We're just stretching out a circle. And with the two equations, some things to note. Again, h and k, we know that that's our center. Okay? And then our denominators, we label them as a squared and b squared. Now the values of a and b talk about how much we're stretching that circle in each direction. A has to be the largest value because a refers to our major axis. So a squared must be larger than b squared. A squared has to be the largest. And the way that I think it's helpful to kind of remember that is a relates to the major axis. Okay? A relates to the major axis. We got an A, major, bigger, biggest. Okay, major. A refers to the major axis. It's the length of what we call the semi-major axis, which is just along the major axis from the center to the edge. And it goes from center to the vertex at the edge. B refers to the minor axis. B refers to our minor axis. And so that's going to be that perpendicular direction going perpendicular from the major axis. On the edge, we have what are called vertices on the major axis. And then on our minor axis, these are our co-vertices. Okay? So on the long distance across the ellipse, the endpoints of the major axis are the vertices. Across the short end of the ellipse, the endpoints of the minor axis are the co-vertices. Okay? So we have 4 vertices, the major ones, and then the co-vertices. B, again, refers to that minor axis. B needs to be smaller than A because this distance is smaller than this one. Now, the difference between the two formulas is which variable gets the A value and which one gets the B. Since A has to be largest, whatever value is, whichever variable has the A value for the denominator, that's going to be the dimension that is longest. So when we're underneath the x minus h squared over a squared, and that is our largest, that's what gives us our horizontal parabolas because that x distance needs to be the longest. But if our largest denominator is underneath our y variable, that gives us the vertical ellipse because that y value will end up being the largest for that major axis. And so you just need to look really carefully to make sure. I don't have to write the y value first. A lot of times you will still see the equation like this, but a and b are switched. And so if you have x minus h squared over b squared plus y minus k over a squared, then you need to recognize that, okay, well, I see the x's first, but this denominator is larger. That means that it has to be a vertical parabola because it's on the y value, okay? So that's what you need to look for to determine which direction your ellipse is going to be wider. Is the largest denominator under x or is the largest denominator under y? And then our focus, our foci that are inside of our ellipse. We use c to represent that distance from center to focus. And we have this formula here. What does that formula remind you of? Okay, which is our Pythagorean theorem, right? Well, it's not exactly the same. This one switches a and c. Now it's b squared plus c squared equals a squared. So it's not really the Pythagorean theorem, but it is a Pythagorean relation. Okay? It's a relationship very similar to that. And the reason is a has to be this largest distance. Of the three variables or values, a is the largest. Or our hypotenuse in a right triangle is also the largest. If I were to draw a line going from the focus to the minor, the co-vertice, that line is the same length as the distance from the center to the major vertice. And if I look at that, I can see, hey, I have this right triangle here, which is why we get that Pythagorean relation. We're just using slightly different variables because a has to be the largest, so it has to equal a. An easy way to remember that c refers to the focus is that there's a c in focus. Okay, so a for major, c for focus, and then b is what's left over. I don't have anything clever for minor. So that'll help kind of remember that. And so we're going to be looking at a couple different ways of writing our equations, how to read the equations, how to graph. The big key things are knowing where the center is, and you have to know the values of a, b, and c. Okay? So basically most of our work will be going into finding the center and calculating a, b, and c. We will have to do some completing the square if we don't have it in the correct form, and we'll go through that shortly. So we want to state the center, the vertices, and the foci of the ellipse with the given equation. Now, just as a side note, when it says vertices, it's usually only referring to the endpoints of your major axis. We're going to do all four right now just so that we have that, but generally when they're referring to vertices, it's just the two. Okay? Otherwise, they'll specify the vertices and the co-vertices. So we need to get it in our standard form, and our standard form has fractions. Does this have fractions? No. So we need to get it to have fractions, which means we have to kind of divide. Now, what's really important to note about the formula is that it's set equal to 1. It's always equal to 1, which kind of makes getting the fractions a lot easier. What can I do to change this so that it's set equal to 1? Divide by 4. So the last step, we don't have to complete the square here because we only have the two variables. We don't have a linear x, we don't have a linear y. So, but the last step will always be divide by this constant term on the right side so that it becomes 1, and then that's where we're going to get our fractions from. So divide everything by 400. Okay? So 16 over 400, we can use our calculator just to kind of make this a little bit faster. When you do the division, you're going to get a decimal. We need it as a fraction. So just as a reminder, under the math button, that first option for fractions, we'll take any decimal and convert it to a fraction for you. So that'll make it a lot easier to simplify those. So 16x squared over 400 will reduce to just x squared over 25. We do the same thing with the y squared, and we're going to get y squared over 16 equals 1. Now, since I don't have an h or a k value, where is my center located? At the origin, 0, 0. So we know our center is going to be 0, 0. And then before we evaluate, or before we try to figure out what our vertices are, what our foci are, you want to figure out what direction your ellipse is going to be. Is it going to be a horizontal one, or is it going to be a vertical one? So looking at this equation, which denominator is larger? 25. And it's under which variable? X. So is it going to be horizontal or vertical? Horizontal. Largest denominator under the x variable. So we're going to have a horizontal ellipse. Sometimes it's going to be helpful to draw this because it's going to, if you're having a really hard time visualizing the points in the relationship to the center, just a little sketch can go a long way in making sure that you have everything going in the correct direction. So we're starting at our center, 0, 0. Okay? So from center, my vertices, are they going to be left and right or up and down? Where are my vertices? My vertices. Co-vertices will be up and down. The major vertices, left and right. Your major vertices are always going to be on this axis. So from center, we're going to go left and right, whatever our value for A is. So from 0, 0. Is that going to change the x value or the y value of our vertex? Or sorry, of our center? We're going left and right. Changes the x. We're going left and right, we're changing the x value. So for our center, in order to get our vertices, when we're dealing with a horizontal ellipse, it's going to be the x value plus and minus whatever we get for A. Whatever our A value is, we're going to go left and right. If it was a vertical ellipse, we would have plus and minus to the y value, whatever the y value was. So let's go ahead and try and look at what our A value is. So comparing this to our formula, x squared over a squared plus y squared over b squared, where do I look to find A? So 25 is a squared. So what does A equal? 5. So we're going to take our x value and we're going to add and subtract 5. So we get negative 5, 0. And we get 5, 0 for our vertices. Negative 5, 0. And 5, 0. Now for funsies, I want to go ahead and also find the co-vertices along the minor axis. Where will those be in relation to our center point? Our co-vertices, where will those be in relation to our center? Bottom. Major vertices, since they're left and right, our co-vertices will be above and below. And the distance from center to co-vertices is B. So 25 was A squared, means A was 5. What's B going to be? 16 is B squared. So 4 is B. So we're going to go 4 units above and below center. How is that going to change our center? Are we going to change the x values or the y values? The y values. We're going up and down. So our co-vertices, we take our center and we're going to add and subtract B, which in this case is 4. So we get the points 0, negative 4, and 0, 4. Okay, Okay, so we've got our center, we've got our vertices. Now we just need our foci. What letter do we use to find our foci? C. So for our Pythagorean relation, it's not exactly the Pythagorean theorem, it's Pythagorean relation. B squared plus C squared equals A squared. Just remember, A is the biggest. A is always the biggest. A has to be the biggest. So we need to solve for C. Well, what's B squared? 16. It's right there in the formula. We don't know C squared. What's A squared? So we get 9 for C squared. So what does C equal? 3. So our C value is 3. So we have to figure out where our foci are going to be. So from center, are they going to be on the major axis or are they going to be on the minor axis? Our foci run on the major or minor? On the major. Is our major axis running left and right or up and down?
Left and right.
Left and right. So from center, we'll go left and right C units to get our foci. Is that going to be adding and subtracting the x or the y? The x. So for our foci, we'll take our center and add and subtract the C value to x. So we're adding and subtracting 3 to get negative 3, 0, and 3, 0. Negative 3, 0, and 3, 0. So those are all our key points. Our center was at the origin. Our A value was 5, so we went left and right 5 to get our vertices. Our B value was 4, so we went up and down 4 to get the co-vertices. Our C value was 3, so we went left and right 3 to get our foci. If we had a vertical parabola, we would just change whatever we did to the x to the y, and vice versa. We'll do that momentarily. Questions so far? Oh, doesn't that look fun? What's some of the major differences between the equation we just had and this one? More numbers, I got more x's and y's. So I'm in general form, not in standard form. Just like with our circles, we'll have to complete the square. Very, very similar process. We'll just have one more part as doing completing the square than we will with circles. So with circles and with ellipses, what's our first step for getting it into standard form? Group our x's and y's. What else? Fraction will be that last part. Before I can complete the square, I need to do one more thing. Put the constant on the right side, so we'll subtract 100. So let's actually erase that. Do that as part of this step. Okay, so now we have to complete the square with each set of variables, here and here. But because we have that leading coefficient, we have one extra step. Factor what? Can you be more specific? So we want to factor out, but not the x and the y. We just want just the coefficient. So we're going to factor out 25, leaving x squared plus 4x, and then we'll put in our box for completing the square. And do the same thing with the y's. 4 y squared minus 10y plus something equals negative 100 . What did I forget on the right? I left something out. Multiplying by what? 25 and 4. So since we factored out 25 and 4, we do not want to forget multiplying by 25 and 4 on the right. All right. What's going to go in the red box? 4. 4 there. 4 there. What goes in the teal box? 25. Okay. So on the left, what do we have when it's factored? On the right, what do we have when it's factored? And negative 100 plus 25 times 4 plus 4 times 25 equals So we've completed the square, now we just need to finish getting in standard form with one last step. Divide everything by 100. So x plus 2 squared over 4 plus y minus 5 squared over 25 equals 1. Which direction is our major axis going to run? Horizontally or vertically? Why do you say horizontally? So that would mean vertically. Bigger numbers under the y, so we're going to go vertical. So, I've been teaching the ellipses for years and I could still never draw one. I always end up looking like that. Okay. So we've got a vertical ellipse. Where is my center? Not on this one. We have h and k now. Get 2, 5. Okay, so we have our center at negative 2, positive 5. We actually have to see that in. There's our center. If I want to find my vertices, where will they be in relation to my center? Above and below. Is that going to add to the y value or the x value? So our vertices will be at negative 2, 5, plus or minus whatever we get for A. Covertices. What about those? Where are those located? Left and right. Is that going to change the x or the y? So, negative 2 plus or minus. What letter do we use to represent the distance to the covertices? B. So whatever we get for B, we'll add and subtract it to negative 2. That's going to give us our covertices. Foci, where are those going to be? Where are foci going to be? Also up and down. So, just like with our vertices, we're going to add and subtract to y, but instead of A, what are we going to use? C. So, I like to do this just to kind of keep track of what's going on. Do you have to write it exactly like that? No, but you want to make sure that you're understanding where their relative positions are, because it's really to get confused about the location of these points if you're just trying to keep track of it in your head. So some way for you to identify and track, am I changing the x, am I changing the y? Which direction is my major axis? Which direction is the minor axis? Where are my foci? Where are my vertices? Okay? And so once we've kind of figured out what we want to do, we just need the values of A, B, and C. Okay? So let's look for A. Let's start with that one. where am I going to look for A for my major axis? The biggest number. What's the biggest number? 25. So 25 is A squared. What does that make A? 5. So we'll add and subtract 5 to our center, which gives me what 2 points? -2, 0. And what's the other one? -2, 10. There. And there. So we've got A. All right, where do we look for B? B will be 2. Where did we get that from? 4. And so we're going to add and subtract 2 from -2. Giving us 0, 5, and -4, 5. Here and here. And what do we use to solve for C? B squared plus C squared equals A squared. B squared is 4. A squared is 25. C squared is 21. Now, last time we found C was a nice pretty integer. Can I square root 21? No. Most of the time your C value is going to be irrational. There's not a whole lot of ellipses that we can do without getting really obnoxious and huge numbers. A, B, and C would have to be a Pythagorean triple in order for that to happen consistently, and so there's not very many of those. So a lot of times C is going to end up being a radical. So C is the square root of 21. So that when we plug it into this little formula that we have for our foci, we're just going to leave it as it is. We're going to say it's -2, 5 plus root 21, and -2, 5 minus the square root of 21. If you needed to plot and graph your foci, then you could calculate that and estimate it. You would round it, and so 5 plus the square root of 21, I have it somewhere, is approximately 9.6 and 0.4. If I did 5 plus the square root of 21, I would get about 9.6. If I did 5 minus the square root of 21, I would get about 0.4. So if I need to plot those, then I would just get those close. Okay? But if you're just giving the points, and it says to leave it exact, well, then you're going to have a longer ordered pair than you're used to writing. Okay? So there's our foci here. Co-vertices here, and our vertices here. Questions on that? All right. So that's all the completing the square we're going to have to do. Everything else is just going to kind of be working from the equation to identify some of those features. So again, it all comes down to center, which is H and K, and we need A, B, and C in order to get our vertices, our co-vertices, and our foci. So looking at this equation, let's start with our center. Where's our center going to be? 0, 0. Center is H and K. There are no H and K's here, so we're starting out at 0, 0. Okay? Next, we want to get our vertices. Which direction is this ellipse going to go? Top to bottom. We got another vertical one because our largest denominator is under y squared. What value do we need in order to get our vertices? We need A. What is A going to be? 5. So, where are those two new points going to be if A is 5 and we're going vertically? 5, 0, negative 5. 5 up, 5 down. What about our co-vertices? It'll be 2. B is 2. So where's our new points going to be? Negative 2, 0. 2, 0. Here and here. And in reality, that's all we need to draw our ellipse, is we just need our vertices. And we can just take it and go struggle to draw an oval, as I have for years. But if we need to identify our foci, let's go ahead and do that as well. What value do we need for our foci? And how do I find C? Okay, so 4, 25. So we get C squared is 21. C is the square root of 21. And so if I want to plot those, we need to figure out what is the square root of 21. And we see that we get approximately 4.6. So we'll just go up and down about 4.6 to get our ordered pair. So up 4.6, down 4.6. Doesn't have to be perfect. Close enough is fine. And if we need our ordered pairs, we have 0, square root of 21, 0, negative square root of 21. A, B, and C. Graph all our points. Where are we going to start? Negative 4, 1, which is what? What is negative 4, 1? Center. So start at center. Okay? Now what do we need to do? Go to vertical 1 again. Okay? Keep going. 6 is going to be what?
6 up.
6 up and 6 down. 6 is our A value. Our largest one is A squared, so A is 6. And since we're going vertically, our vertices will be 6 up and 6 down. So 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 6. Okay. We can add and subtract 6 from the y value. Add and subtract 6 from the y value to get our vertices. Where will our co-vertices be? 4 to the right, 4 to the left. So 4 to the left is negative 8, 1. 4 to the right is 0, 1. Okay, so that's all we need in order to draw the ellipse. And if we wanted to find the foci, we would use our Pythagorean relation, but we don't need to graph it, so we're not going to. And we got one more that we're going to do today. So we're going to draw an ellipse with the given information, and then we're going to write its equation. So we're given 3 points. We're given a focus at negative 1, 4. We're given a vertex at negative 1, 5. And the center at negative 1, 1. Okay, there's our center. So we know our center's given. We still need to find A, B, That's all we need to write the equation and graph it. It's just A and B. So given those points, A measures the distance from what to what? Close. I understand what you're trying to say, but let's try and rephrase that to be a little bit more specific. Vertice to what? Vertice to center. So A is vertex to center. So what's A? A is 4. What does B measure? Okay, so it would be horizontal, somewhere left and right. I don't have that point, do I? Okay, so we're going to need to use C. We can calculate C from what's given. What does C measure? Focus to what? So C gives me focus to center. What's C? Great. So given A and C, what can I do to find B? Very descriptive.
B squared.
Okay. What's we don't know B squared. What's C squared? What's A squared? So what's B squared? B will be the square root of 7. Now, in order to plot our point, we'll need to know the square root of 7. So we'll just get that there. It's about 2.6. So we have square root of 7, which is approximately 2.6. Okay? So that'll give us our covertices. 2.6 to the left and 2.6 to the right. I need my other focus and my other vertex. Where's my other focus going to be? 3 down from center. 1, 2, 3. And where's my other vertex going to be? -1, -3. So there's our ellipse. Beautiful ellipse. And then we just need to fill in H, K, A, and B into our equation. Since it's vertical, hold on, just hang out for 3 seconds. We've got our H value. We've got our K value. A squared is 16, B squared is 9. Which one goes under the X and which one goes under the Y? 16 goes where?
Under Y.
Under Y, and 9 goes under X. Set it equal to 1. There's our equation. Okay, make sure your largest denominator matches with the direction of your major axis.